Okay, hello everyone. Welcome back to the last session of this course, uh, Deep Learning for AI, Aesthetics and Creativity. It is a great pleasure to have Zoya Bylinskii, who is a research scientist in Creative Intelligence Lab at Adobe, here today with us. And I think this is a happy ending note as well, because Zoya is very um, she's great, and we have talked about her work in the past lectures, especially for visualization and infographics. So her talk today is the title is Using AI in the Service of Graphic Design. Please go ahead, Zoya, and also don't forget our question. Please share a little of your background.
Sure. And you can see everything on the screen fine. Yeah.
Yeah.
Good to go. Okay. Sure. And I'm happy to tell you about myself, but I'll also leave some of that to maybe the discussion at the end. So anyone can ask questions about my experience and my path. But just very quickly, I've been a research scientist at Adobe for just over the last 2 years. Prior to that, I was a PhD student at MIT, where I did interdisciplinary work between computer vision graphics and human perception. That led me to an internship at Adobe with Aaron, actually. And so from then on, I was basically hooked onto this space of perception for graphic design. And at Adobe, currently, I get to do the research that I love together with the applications that excite me. And so what I'm really excited about is this interface of graphic design and AI, which is the title of my talk. And that's because compared to other computer vision and image processing tasks, this is a much sparser space. It has room for growth, innovation, and of course, lots of creativity, which is what your course is all about. So why do I think graphic designs are so interesting for AI tasks? Well, they come in diverse stylistic forms: posters, applications, UIs, websites. And what's in common to them is that they tell stories in creative and eye-catching ways. They're a combination of text and pictures that can draw our attention, walk us through a message, and most importantly, affect our behavior. So they really get us to go somewhere and do something, at least in normal times. And in order to do so, they've been carefully crafted by professionals with excruciating detail to color palettes and layouts and typographical choices and visual assets, and how they come together on a page based on this underlying also understanding of human perception, how the design content will be viewed, interpreted, remembered, attended to by the consumer once presented to them. So the question I want to ask is, how can we take this complex design process and deconstruct it into the computational modules that we can then automate by learning from real designs, design collections, and real design workflows? So in the talk today, I hope to give you a little bit of a taste of how AI can make it possible to achieve these goals. But before you protest about maybe the future of creativity, I do want to point out that the intention here, at least my intention, is not to replace the designer, but rather these twofold goals. One is to automate tedious tasks, and the other is to enable rapid exploration for the designers. So all of this while keeping the designer central to the process and curation of the design. So what do I mean by these two goals? Let's look at a couple examples. A repetitive task worth automating is the resizing and laying out of a design for different form factors and aspect ratios. So this is a very, very common design task, and that's because of the diversity of devices and web platforms on which promotional material often appears. So an AI-enhanced future is one in which the designer will compose the initial assets, so they're part of the initial design, but then all these other variants can be generated automatically. And otherwise, this would be quite tedious, repetitive work. An example, on the other hand, of where rapid exploration occurs a lot is when designers are tasked with, for instance, creating an icon, a logo, or a similar design asset. where they must cycle through many possible visual representations before they settle on the design that conveys the intended message, that conveys the branding that their client wants. And so there's a lot of back and forth and iteration that must take place. Here's another example. This is straight out of an Adobe product called Adobe Spark. So if you haven't seen it before, Adobe Spark allows the user to import images and text, and within seconds, they can cycle through dozens of layout variations of the content, as you can see here. And this is AI automated. There's articles about this that I can share with you if you're interested to learn more. But critically, what such an application can enable is for a designer's or a user's design velocity to increase. They're still part of the curation process. They're still part of fine-tuning the design, but they can cycle through variants much more efficiently. So what I'm going to do with the rest of the talk is really go deep into two projects that I've worked on recently in the space of design automation. And we'll see how those examples of tedium reduction and design iteration come into play in these projects. So I'm going to start with a project about predicting visual importance for graphic design. So this has been done in collaboration with my Adobe colleagues, including Aaron, who you just heard from, as well as MIT students. Part of this project started when I was an Adobe intern, but I'm going to talk about the more recent component that was presented at the last User Interface and Systems Technology Conference, or WIST. So let's say we start with a diverse set of designs like these, like I showed you at the beginning. Our goal in this project is to learn what in different designs is eye-catching and visually important. Because if we know this, then armed with this information, we can use it for downstream applications like design retargeting, which I showed you before. So in order to understand what components of a design are visually important, we invoke this Importantnots annotation tool. So this is built on our own and others' prior work. So in this interface, as you can see here, crowd workers are asked to mark design regions that they consider important. And this is a somewhat subjective task, but then we can gather a whole bunch of annotations from a whole bunch of participants, and we average their annotations together into heat maps that look like these. And after about 30 to 40 participants, the results start to stabilize. So we see consistency in what people see as the important parts of the design. Now, in other papers, we have showed the relationship between the data gathered from this kind of annotation task and other measurements of human attention. I won't go into this, but as a takeaway, our importance annotations can be seen as a proxy of visual attention. So in all, we use this annotation tool to curate a data set of 1,000 image annotation pairs, so original designs and then importance heat maps, that cover 5 design classes: ads, infographics, mobile UIs, movie posters, and web pages. And we also tag along a data set of natural images with corresponding saliency maps as an additional component of the data set. So we take all of this data in as training data for our model of importance. And this model uses the class-based information, so it has a classification module, and it predicts the probability that the input image is one of those design classes or is a natural image. And that classification module is also used as input to the final heat map prediction of importance. And the model is a pretty standard encoder-decoder with multi-resolution features. So given its speed of test time, this model can be deployed within interactive workflows. So here's an example workflow. A designer might upload an image that they want to convert into a poster and advertisement, and they're iteratively building in design components. And so what we propose is, in the background, we can show the designer what are currently the most important, salient, eye-catching regions of the design that they can use as guidance for placing other objects or elements in the scene. So you can see here that initially we have a natural image as input, and our model predicts N. So that's the class prediction that's most likely a natural image, and it predicts the most salient regions Then the designer puts a piece of text in the region that's not eye-catching, so it's not going to be distracting. And then the designer keeps adding on elements, and our model is in real time recomputing what is currently the most attention capturing object. And so the designer can check that the regions that are indeed the most attention capturing are the ones that where the main message lies. So as a proof of concept, we indeed took our model and put it in an interactive design tool. So this is a prototype that we built. So what happens here, it's a design canvas. The users can bring in various elements, text and image pieces. And what you should be seeing that on the right-hand side, a heat map evolves. So in the back end, we're actually constantly recomputing the predicted importance of the current design. So you can see as elements are moved and dragged around, this heat map is continuously being updated. And this is not super resource heavy. This is a pretty small neural network that can be deployed. The other thing that you're seeing is that there's a histogram right below this heat map where you have the current predicted importance score for each of those elements. And this is just obtained by averaging the importance in that region. So the cool interaction that the user can have, I'm going to try to skip a little bit, is what they can do is they can adjust the importance level of each element and say, actually, you know what? I want this element to pop out more, or I want this element to be less attention capturing. And when they click optimize, what's happening in the background is a genetic algorithm is manipulating the design in various ways, moving around, resizing the various elements until the user's objective is achieved, until that element has the target importance value. So just going forward a little bit, so you can see that the design program will supply the user with new variants, and they can continue this iteration process together. So the designer remains in the loop. So that's one application. And another application is design retargeting, a common one, as I mentioned earlier. Here, given an initial design and an algorithm that can generate a bunch of variants like the genetic algorithm I showed you in the previous example, what we can do is user importance predictions for selecting the most viable candidates. So the best retargeted versions given this target aspect ratio. So the way we use importance is we want to preserve the designer's intent. So if an element was most important in the original design, we want to ensure that it remains the most important or attention capturing element in the final redesign. So we use importance to re-rank all the possible redesigns and then display the best ones we find. And so we actually implemented this as part of a real design tool just to see how it would work. So you can see that users can assemble their design. It's a vector design program. They can interact with individual design elements. And again, if I, let me find the next step. Yeah. So if the designer wants to see alternate layouts for a particular aspect ratio, the ones that are offered to them come with this attention guidance. So the versions that they see are ones where the importance of the original elements is preserved in these retargeted variants. So both of these applications offer us promising new directions for how importance models can be used within AI-assisted tools, graphic design tools. So that's one of the projects I wanted to do a deep dive into. The second one, if we switch gears, is icon generation ideation, another kind of graphic design problem. So this project was also done with colleagues from Adobe, colleagues from Harvard, the City University of Hong Kong, and Boston College. So I'm sure you're regularly exposed to icons. I don't have to tell you that they're commonly used to navigate websites and manuals, to advertise what different companies specialize in, and to serve as an internationally understood visual language. And for those that don't know, there's common icon repositories like the Noun Project. They allow you to find icons that correspond to common visual concepts. And that's actually also the limitation of such icon repositories, that they'll contain the visual depictions of common concepts like pizza delivery. But if a designer wants to remix and design a visual for a new concept, like say sushi delivery, the onus is on them to do this manually, because they won't find, they might not find those depictions. And what we did is conduct some interviews with icon designers to figure out what their workflow in this case is when designing novel iconography. So such a workflow might look like this. They might be searching for sushi delivery and not finding it. They look for related concepts like pizza delivery. They use it as inspiration. They recognize that delivery is often represented with trucks or with phones. Then they borrow one of those ideas and try to recombine it with the visual concept of sushi. And then they need to find icons that are stylistically compatible. Once they do that, they download those icons, they upload it into their favorite design application, and then they recombine and further edit to make sure that indeed the final output looks stylistically whole. The designer then has to repeat this process many, many times again if they want to cycle through different possible design variants and combinations. So we were motivated by simplifying such a icon ideation workflow, and we designed an AI-driven pipeline for compound icon generation. So here's an example. The user searches for business contract. We show them various combinations of simpler icons that convey this message of business contract. And we let them very quickly cycle through different stylistic variants. So by clicking on any constituent icon, they can cycle through what do different stylistic versions of this icon look like within the full icon. And the ones that we surface at the top of the search are ones that we've evaluated to be most compatible. So here's another example. The user searches for a concept that doesn't exist, maybe for a new kind of company. And so the icons they're going to see first are the ones that we have ranked based on various AI criteria as being the most relevant and compatible for this concept. But we still give the user back control if they want to vary any of the styles or the layouts and placements of those components. Okay, and how's this system built? Well, we created, based on our interviews with icon designers, a 3S icon design framework. And the idea is that it combines space, style, and semantics together to synthesize compound icons. So it lays out the icons in a stylistically compatible way, while ensuring that the mapping holds to the semantics of the query. So let's break this pipeline down by looking at an example. Let's say the query is eco-protection, and this is the final results we want to generate, some example icons for this concept. Here's our full computational pipeline at a glance that invokes these semantic, style, and space components. So let's take a look one by one at the components. Given the query as input, what we do is break it down into words, and for every word, we go and look at this dictionary that maps abstract concepts to concrete nouns. So for instance, it will map eco to leaf and tree. And then for abstract concepts that don't occur in our dictionary, for instance, like protection, we look in a text embedding space for related concepts for which we do have a mapping. So for instance, in this case, protection gets mapped to insurance, and insurance then maps to the concrete nouns hand or umbrella or shield, because those are the ways in which that concept has been visualized before in previous icons. So this is, of course, all trained on existing icons, because otherwise you wouldn't know that insurance is related to hand in any way. They're not semantically related concepts, but they're related concepts in icon space. Then the next step is for all those words that we generate that are related to this input query, we find all the icons that are stylistically compatible, pairs or triplets or more of icons that are stylistically compatible that can be combined to convey this notion. And so this is trained using a triplet loss, where we use an existing icon data set that we scrape to learn that components of a single icon are more stylistically related than if we jumble around components from different icons. And that's enough to learn this embedding space to then suggest icons to be put together if indeed they're stylistically compatible. And then the last step is just to figure out the layout for those constituent icons. So we use a template-based approach where, again, from existing icons, we know that if you want to put something together with the hands, that item should be above the hands. If there's an umbrella, it should be below. If it's a shield, it's inside. And that allows us to then recombine and create the final outputs. We train these various components using the CompiCon 1K data set that we gathered ourselves. So it's 1,000 different compound icons where their individual components have been annotated and mapped to labels for training this system. So here's some examples of our automatically generated results. You can see more common concepts like smart car, and then stranger ones like rabbit insurance that suddenly becomes possible here. We evaluated our pipeline as part of an application where you might want to create a pitch deck very quickly for a new business venture, for new products. We gave users compound concepts like smart cars and secure cloud, and asked them to create compound icons using standalone design tools or using our Iconate quick ideation platform. And we showed that they can do this much quicker. So maybe in some future instantiation of Google Slides or Microsoft Word or another similar application where you're importing icons, you won't be limited to the icons currently there, but you might be able to quickly have an icon generated for whatever concept you can think of. So that wraps up the second project I wanted to do a deep dive in on. And these are merely two examples of this broader theme of graphic design facilitated by artificial intelligence. So this is one of my favorite quotes that I think encapsulates a lot of the research that I do, which is that we're on this verge of another revolution as artificial intelligence and machine learning turn the graphic design field on its head. Again, the again refers to points in time when digital graphic design tools became the norm. And so they facilitated a lot more design workflows. They did not remove creativity from the designers, but they gave them larger pieces to start working with and assembling into even more amazing designs. So I want to give you kind of a brief overview of some of the other work in this space. This isn't my work, but just to give you a taste that yes, with AI, we're seeing more and more work that applies artificial intelligence to design and creative problems. So for instance, this work on logo synthesis is similar to our work on icon synthesis, except that logos are not real visual depictions of concepts, rather they're abstract shapes and pieces of text that get combined together in these pleasant and memorable forms. And so what you're seeing here is the top is the samples from the large logo data set that the authors collected. And at the bottom is Wasserstein-Gans generated logos as well. So these look distorted in various ways, but again, what they're claiming is not that this would be the final output for a logo, but that it would facilitate this quick iteration ideation process that designers might want. Kind of give them inspiration, but you have them run with it. And in the end, the designer is still the creator. Here's another piece of work in this space, and Aaron is a co-author on this work. And here the input is a randomly placed 2D graphic elements, and their network refines the geometry of those elements to produce a realistic layout given various layout constraints and also the semantics of those elements. So those elements can be paragraphs and figures and tables. You might want to figure out how to do a layout for a magazine page or for a document. So other than documents, this paper shows applications for mobile app layout design and web page optimization, and there's a few other applications sprinkled throughout. This is one work in a line of a number of papers that take as input user text queries, like 32% of us use at least 2 types of social media every day. And as output, they create this small infographic, which is like a mini design. It contains a piece of text, it contains a statistic, and it contains a small visualization of that statistic, maybe with an icon. And this is very similar to our compound icon generation work in that part of it is AI driven and part of it is template based. And then there's various refinement modules to make it look like a finished product. So there's quite a bit of work in this new space as well. And the other thing that I did want to mention is that there's not a single home for work like this. This is spread across different communities. So you really have to know where to look. Some of the work that I've published is in HCI communities. So it's published at CHI and WIST. This work is in a visualization conference. Other work is in computer vision and computer graphics. And maybe someday we'll have a conference just dedicated to computational graphic design and computational creativity, where we'll see all this work together. Here's another example from computer vision where GUI designs are generated using GANs as well by borrowing components from existing GUIs and then proposing a new GUI design given some user specified constraints. So if all of those examples get you excited and inspire you and you want to get your hands dirty, there's many places you can start that have great resources available. So all the work that I've presented so far has been published, and along with all of those pieces of work often come data sets. So for instance, our Iconate project comes with, we provide the model code, we provide all the GUIs, the annotation interfaces, and 2 repositories of data. One is IconVoc 152, which is a vocabulary of 152 basic icon concepts that can be recombined into many different kinds of abstract concepts. We also have a data set of 1,000 compound vector icons that we have manually segmented into components and pieces, can be used for other applications like segmentation and also the reflow. Visually 29K is a data set that's part of my other work on parsing and understanding infographics and summarizing them. And that is a data set of 29,000 infographics that have been organized into categories, annotated. Thousands of them have been annotated with icon bounding boxes. And also this data set comes with 250,000 icons that have been organized into categories like health and automotive and business. And what we've published on and how you can use this data for topic understanding of infographics, for detecting visual regions, and for summarizing those infographics. So for the sake of time, I chose not to go into detail on this project, but the resources are all available on this website. And there's a related initiative that we were inspired actually by called RICO, and it's a giant mobile app data set that comes with over 9,000 Android apps and 66,000 unique app screens and user interaction traces and segmentations that can be used for all sorts of modeling problems like UI layout generation or interaction modeling and user behavior analysis. This one, the Behance artistic media data set, is one that was worked on by Aaron as well. They make their data set available, and you can see on their data set ways to search and find images from that data set. So this is based on Behance, which is a portfolio website for professional and commercial artists. It includes photography, drawings, illustrations, basically 2.5 million images with different attributes that have been either automatically or manually obtained. And the last one that I'll mention is this automatic understanding of image and video advertisements data set from University of Pittsburgh. And that data set contains 64,000 image advertisements and over 3,000 video advertisements, and provides a space for exploring symbolic references in advertisements and high-level semantic understanding and story understanding. So this is also a very exciting data set for work in this space. So now we've seen work that attempts to automate various components within a design workflow. And if we plot all these available models and tools and data sets on two axes, what we would see is that a lot of the automatic tools are not very creative. Some are kind of verging and kind of on the direction to be more creative. But then there's also a lot of very creative workflows that are not well automated, and the space of automated but highly creative workflows is still ripe for future discovery. And so as students, this is a great place to explore. So I started the talk with why I'm excited about the space of computational design. I'm going to end on the same note. So this is two pictures of my bookshelf at home. And while you might expect these two sets of books to appear in different contexts and be read at different times, actually, I find myself cracking open books from these different shelves for the same project. And that's what generates an amazing flurry of creative interdisciplinary thoughts. And so those interdisciplinary thoughts, they in turn lead to exciting applications at the interface of computation and design. And through the talk, I hope that I've motivated you to explore this space yourselves. And I actually purposefully left a whole bunch of extra time for questions and discussion, because there's many projects I didn't go into, but let's stop there and have a discussion. Questions?
Thank you so much, Zoya. Are there questions for Zoya? Guys, don't be shy. Let's make a good conversation and learn. So let me ask this question first. It was a really interesting presentation. Thank you so much, especially that you also gave us some glimpse of other data sets. Often students and other people, audience ask me that what are the data sets if you want to work on. So that was great. But also for your work, probably you have already been thinking about it, but I just want to know if you have a comment on what if someone wants to give you a text and say, generate this type of icon for me, like describing the icon by text. Have you started or are you thinking of doing something with that? So they get as input, get the description of the icon and then generate it.
And the output is the final icon, you mean?
Yeah.
Well, I mean, this is the input and output for our current iconate system, but the limitations of that one, of course, is that it recycles pieces of existing icons. So it's not generating things completely from scratch. But what's really promising for those who follow OpenAI is their new DALL-E model that we hope to get access to soon, that allows you to type in search phrases and get all sorts of uniquely generated novel outputs, visual outputs. So I'd be excited to take that, and even though they do have examples that are in the graphic design space, I want to dig in more and see where those are coming from, whether they're sampling the broad sets of graphic designs, and whether we can improve upon them and make something more tailored to, say, icon creation or UI creation. So that space is still to be explored. A lot of the papers that you're seeing right now that do text to visual in the graphic design space specifically are borrowing components of existing designs. And that's partly for a reason, because graphic designs are less forgiving than natural images, in that you can't really have these blurry lines as landscapes do. Graphic designs need to be composed out of crisp vector graphics. And so unless you're reusing components, or unless you have a more sophisticated network that can generate vector graphics, which there is some work in this space, it's hard to create something that looks like a reasonable, almost human created output entirely automatically.
It's a very good point. Yeah, part of the reason actually I asked this question was um, something like Dolly or Clip that because I saw, for instance, you were describing that, okay, you want this hand, but you want on top of the hand to have, this bone or something, and finding this compositionality with language is something that apparently on the scale, Open AI is getting some success on that. So it would be interesting to incorporate that.
Indeed, yeah.
And then also, but also we talked about one of your works where you learn the associations of uh, icons or infographics and the text around them or next to them. So that's also a good point to remind us about, this associations that you learned.
Right. Yeah. So, I mean, that project, it's part of the Visually data set that I just showed you a few slides back. And their main goal was, I'll tell you that the original goal was take as input an infographic, which is essentially a really complex graphic design that attempts to tell a story about, or rather convey a piece of information. Right? So it's usually a combination of text, stats, graphs, visuals. It's quite complex, unlike maybe a product ad that could have just a single object and a piece of text. Infographics tend to be on average much more complicated. And so the original goal for the project was, given an infographic as input, produce a caption as output. So this is for in order to more quickly search through infographics that are on the web and pull out components, but also to annotate for the visually impaired. But then upon starting this project, the realization was we can parse the text quite well. So Google's text parsing API is quite good, different fonts it can handle. But we didn't find anything that could extract visuals and icons from infographics, because object detectors are trained on natural images, and there's a very big domain gap, and we couldn't use existing object detectors for our purposes, which led us down this rabbit hole of figuring out a way to train an icon detector with very little data and creating synthetic data. And eventually we could detect the icons. And that led us down a few other directions that students had worked on, about, let's say, can you learn joint embeddings between the icons that you detect and the text that occurs nearby? Because as self-supervision signal, you could learn about how various abstract concepts have been visualized because they co-occur together in complex graphic designs like infographics. So this space, like, as I mentioned, is really ripe for further exploration, and there hasn't been too much published. So actually the title of my whole presentation is really thanks due to Aaron, because for some paper that we co-wrote together, there was so little work in this space that we could title a subsection of the related work AI in the service of graphic design. And so I use that as inspiration for this talk as well.
Very cool. Cool. Other questions?
Okay, hi Zoya. Hi, my name's Adrian. I'm not part of the course. I had a question. I thought it was funny or interesting that your talk, like part of the point of the talk was that you help designers as opposed to, replacing them. And that's something we struggle with all the time in medicine because, we try to convince doctors we're not trying to replace them. And I was wondering what you think is kind of like the order of importance. So right now you're trying to replace the most mundane things, right? Is what you're saying. But you can imagine, like, really far into the future, you can do an awful lot of this work. Like the AI can do a lot of the work, and maybe the designer just chooses the optimal design, and like that's their entire job. So I'm just wondering if you can think of like what is the hierarchy? What is the thing that makes the designer the most precious? You know, like the most like what's the thing that's going to be hardest to replace?
Part of it is the curation itself. So we can create a whole bunch of things for them to look at. And a bunch of it is going to look quite good. And then a bigger part of it is going to look like complete garbage. And the metrics for figuring out if something is actually reasonable, those are the hardest to train. You could train them on, real existing designs, but the whole point of creativity is to create something that hasn't been created before. We can do things that reuse components, but we can't do things that are out of that manifold entirely. So we can use designers in two roles. One is to bring us out of that manifold and create some assets that we wouldn't otherwise be able to generate. And then we can operate on those assets automatically. So as a very, very concrete example is like cartoon characters. Every cartoon comes up with their own, visualization of faces and body parts. And maybe some of them are reminiscent of other ones, but they're never really reused components. They're really quite novel in the abstract representations. And that's where you need people to come in and just bring you out of the manifold of existing characters and introduce a new one. Once you have that new one, you can automate, moving their mouth or body parts like you've seen other characters moved before. So that's where you can do transfer learning, but you need the designer's first step, kind of first push. And then the second part is the curation. We don't always know if we generate garbage. And so we either need designers at the training stage to tell us, okay, give us garbage, non-garbage pairs, or sit there and rate everything we've created so that we can use it as further training data. Or if we're working on a pretty different task than what we've worked on before, we still need them at the last stage, even, at test time. We've generated all this stuff. Now they're creating it. And as you probably know, in the medical field, it's nice to give control back to them at the end and say, you know what, if something went wrong, it's your fault. You're the last say on this. And that kind of excuses the algorithms from whatever they don't yet know, and still puts the final control back in the to the people. Because if in the design case, it's less severe than in the medical case, but if you start deploying automatically created designs and advertisements, some weird things are bound to happen.
Sure. Can I ask a follow-up question? I guess I'm interested if you see some a company like Adobe design things that are not static, so like they're somehow tuned to the person who sees them. Like, I assume, I could be wrong, but I assume there's cultural differences, for example, between what people look at or something like that. And I could imagine someone creating the same design, but when I see it, it's maybe slightly different than when my wife sees it or something like that. Is that something people do? Is that something people are discussing?
Everyone discusses it and brings it up, nods,
Okay.
and moves on.
I
So
see.
it's too hard, partly because of the data problem. We barely have enough graphic design data to capture the space of graphic designs. And if you start to segment this into like culture appropriate graphic design data, you have like very little. I mean, there's space, I think, to use various types of transfer learning in a smart way. But I haven't seen much work in the space at all, if at all. Some work from the HCI literature has investigated more the qualitative question of, given a whole bunch of designs, how do they get adapted to different cultures? And there's case studies, but nothing at the large data scale that would be learnable from.
Makes sense. Yeah. Cool. Thank you. And thanks for the great talk.
Discussion.
Thanks for asking questions, Andrea. Zoya, another thing that comes to my mind is that how are these things that you are showing us are, some of them are part of Adobe packages like Photoshop or something, or are they going to become?
Well, so this is maybe helpful to the students to hear. What is the role of a research scientist within a company like Adobe? The ones that I've presented to you today are not yet, but part of the role of a research scientist is, once they publish a paper, and we're after these kind of big blue sky research ideas, can we pitch it in a way where an existing product team within Adobe will be interested to apply it and port it over to their product? In some cases that, that requires simplifications. You can't do the final, text input, final icon product. That's not something that designers would use. There's too many unknowns as part of that process. And if you fail a lot, as a lot of automated AI does, that's not going to be acceptable in terms of product. So we really have to reconceptualize a lot of our problems in a way then makes them portable to products and tech. And so part of my job is kind of pitching my research ideas within the company as if they're little startups. Like, here's what I can do. How can you find how can you find what I've done useful to you? And then let's work together about it. And then you end up assuming a kind of consultancy role in helping that tech transfer forward. And that can take a few years. So the projects that I've presented are relatively recent, in the last 1-2 years. So it'll take some time for them to catch on, but yes, my hope is that they will find a home. Otherwise they'll kind of remain as research prototypes, and that's fine too, because they'll inspire the future generation of research projects and maybe tech prototypes in the future.
That's very cool. And as far as the work that you mentioned, do you also get to work with designers or collaborate with them? I mean, for instance, I know that IDEO is here in Cambridge, and that's a good company, or maybe individual designers.
I mean, we have our own designers at Adobe, a bunch.
Yeah.
Well, one exciting thing actually is that we have, say if you're in an academic position, you're working with your fellow academics. And if you're in a company, you have access to people with very different profiles and experiences. So some of the projects I've worked on have been with designers, some with product engineers, some with UX researchers, and I can make use of their particular skills. So we have we can have a dedicated user experience researcher conduct interviews for our projects, and they're not going to be like student interviews. They're going to be professional interviews when we're going to get out of it the takeaways that are going to helpful in building a product from scratch. Yes, I've worked with some designers as well, and they're helpful anywhere, right? Like from conceptualizing ideas we can go to them and say, you know what, tell us about your workflow and what hurts most. And then we can go from there and compose a research idea. Or we can compose a research idea and go to them and say, is this going to be helpful? And they can come back to us and say, not at all. No designer will use this, but you can reconceptualize it like this. And then we can tailor our project to actually be useful to future designers. Because if we were to do this research completely in isolation, then we come up with problems that we're interested in solving, but apart from being research prototypes, they won't have a future. So this is part of the reason I like being part of a company, is I can get sanity checks from different individuals about, is what I'm doing eventually going to be useful to someone? And if not, how can I reconceptualize the problem to be useful?
That seems very cool and constructive. So here's the question. Some students often ask me that, how can I, like, if I want to go do an internship, what are the tools that I should learn? And also, some of them are actually interested in doing internships. They are in different places in their studies, some of them undergrad, grad. But what is your suggestion for them?
Well, the biggest suggestion is to have a strong computational tool set behind you. that will make you a strong candidate for position as an intern. And there's internships in different places in a company like Adobe. You could be a software engineering intern. You could be a research intern. You could be a product engineering intern or a product research intern. Those aren't the actual titles, but maybe those help with kind of visualizing the types of roles. For those different roles, you might be expected to have or different kinds of skill sets. In all cases, being a technical person is going to help you significantly. So having a strong base in software tools, you know, if you're interested in some of the problems I presented today, then I'd want to see machine learning experience on your resume, right? I'd want to see that not just in course form, but in project form. Give me a GitHub page of what you've built. Show me that you can actually implement those ideas and not just reuse existing models or existing libraries, but innovate, right? And if you can, then you're a good candidate for a research internship, where there's a lot more flexibility as to the direction on which you work on, and there's a lot more unknowns as compared to, say, a product internship, where there might be a very kind of laid out problem task that needs to be solved. They'd also be looking for a particular set of skills. But in research, the set of skills is much broader, but really we want to see, both your technical strength and your ability to be creative, right? Can you go beyond what's out there? Can you conceptualize new ideas? Can you apply them in new ways? And how enthusiastic and excited are you once we get to the interview stage? Those are my suggestions. And in order to get there, what do you do? Well, online courses are one thing, but that doesn't, if you've taken an online course, I don't actually know whether you've just listened to the material or you've actually really deeply internalized it. So being able to show research experience, volunteer or find a research assistant position or a tech position in a research lab in a university. Approach professors and say, I'm available for this amount of time, for this duration of time. I would love to work on these kinds of problems. Can I do that with your students? So being able to get references from other researchers that will say, yes, this person is suitable for research and is creative and technically strong and innovative. I recommend them. That's what we're looking for as well.
Okay, excellent. Thank you so much. So I hope that this gives us a good picture of what are the things that we need to do or we need to learn.
And if there's further future questions, either about the research or about these kind of higher level questions of, industry, academia, internships, email me. I don't know if you're going to make my email available, but you can.
Yeah, I'm going to put your link to your website, and so they can find you, I suppose.
Yep. Also, Googling Zoya Adobe also works. It's not a very common name.
It's a very cool. Okay, any other questions? Well, if no more questions, I wanted to thank you again, Zoya, and it was really exciting and inspiring for us to learn from your research. And I see that also some students are thanking you on the chat. They thought that was very interesting. So excellent. With that, I thank you and everyone, and have a good day.
Thank you for organizing, Ali.
It's a pleasure, my pleasure. Thank you.
Bye.
Bye, Adrian.
Bye.